Hello, we're here today to help you out with writing your rocket project report. This will be the first day. So, your best thing to do is to go to the Pembroke Academy homepage, come down to homework pages, go to Mr. Kelly's site, and then you're going to go to the energy, and you will then go to where it says Rocket Report Rubric. Now this is the rubric that will explain the entire thing to you, step by step, what you will need to do. It also will point out to you that this is for two different competencies. It's for the competencies on skills, and it's also the competencies on mechanical energy. Now, if the little instruction has 4 stars beside it, it will be graded for the first competency. If it has no stars, like this one down here, it will be graded for the second competency. So you'll actually get 2 grades for this. My recommendation is, at this point here when you have this, is to simply go underneath the file and say make a copy, and you can actually go and say a copy of the rubric. You can just say something like, here is Stewart's Dents Rocket Project. Oops. Oh, we didn't do a very good job on spelling here, so I'll go fix that. Yeah. Now, what this does for you is it gives you a nice template for your entire project. So, as you go down through here, you'll see the first thing that you need to have is a title. So you're going to give it some sort of nice title for your that is descriptive to it. Something like the Red Rocket Project, or Rockets in Flight, or Model Rockets, something that will describe the entire project. You'll also see that you'll receive 9 points for each subtitle. Quite often people are confused by what subtitles are, but we're talking about these things right here. So in your report, you need to have introduction. If you get introduction in there, you will have 1 point. In your report, you'll have to have the word diagrams as a subtitle. That's worth 1 point. And as you can see, you go down through. If you don't put any subtitles in, you can lose quite a few points on this project. Now for today, we are actually going to try to get through 4 of these sections, these subsections. So introduction, diagrams, materials, procedures. So let's start with our introduction. Our introduction, first of all, needs to be in a paragraph form. Second of all, needs to be in third person. So you're not going to have, I built this great rocket project, or we went along and made a rocket. It has to be in third person. So something like, for this rocket project, a model rocket was built. Then you want to say why it was, what you did. Basically, it was built. You want to say what was done after you built the rocket, you launched the rocket, and you want to say why we did that. And we did that so we could measure the time in flight, parachute deployment, height, and mass. And last but not least, we also did this so we could calculate average speed in flight, average speed of ascent, and final velocity. So therefore, you're going to have a paragraph here that will say something like, for this project, a model rocket was built. This rocket was taken outside and launched. From this launch, the time in flight was measured, the time of parachute deployment was measured, the height was measured. In the classroom, we measured the mass. From these measurements, the average speed in flight, average speed of ascent, acceleration, final velocity, kinetic energy, potential energy, work, and power were calculated. And that's all you need for an introduction paragraph. Next, you're going to have a subtitle, diagrams. This is a very simple section because in the text part of your report, you are simply going to write under diagrams, say, see attached diagrams. And when you've finished your report, you will attach the two diagrams which you drew in class during the past couple of weeks. You'll attach the diagram of the model rocket and the diagram of the launch site. Now we move on to the next section, which is the materials. This is just a list. Think of grocery list. It's not a paragraph, it's not a bunch of sentences, it's just simply a list of parts. Be sure to include all of the parts that you use to make your rocket. Make sure you list all of the parts for the launch. I'll cover that for just a moment. I'll give you the launch because people have trouble remembering that. But basically we had the launch pad, we had the ignition system, we had 2 stopwatches, and we had the height finder. That's what we took out for the launch. And you also need a complete list of the measurement materials. So there you have the 2 stopwatches, the height finder, and the triple beam balance. So again, you're just making a list of these things. For the list of things that are in the rocket itself, please refer to the rocket booklet. If you do not have your rocket booklet, you can go back to my page. And on Monday and Tuesday of last week, there are a set of all of the instructions there that you can get to. Okay, and it'll tell you all of the different pages. The last step that we're going to work on today is the procedures. So we're going to have a subtitle, procedures. And in this case here, procedures are written in sequential format. So in other words, you have an A, B, C, D. Okay, it's not a paragraph. It is not the directions from the booklet just recopied. You are simply going to do something like A, rocket construction. And then you could have a bullet or a small letter down here or a number, and you would write airframe. Something simple like wrap 3 layers of paper around the plastic mold and allow to dry overnight. It doesn't have to be extremely detailed, it just has to be enough information so that you remember the steps when you go back to look at this that we did, and you can refer back to these procedures. So you're going to do rocket construction, you're going to do one for launch procedures, you're going to do a set of procedures for taking the measurement. That should take you pretty much through the end of today's lesson. We're here on the second day of writing your rocket project, and you should start out by going and opening up what you had the day before. And I'm opening up Stewart's Dent's rocket project, and we left off with the procedures, and we're going to move on to the results. This is once again a very simple section for you to do. You are going to just write the subtitle results, and then you are going to say, please see attached results on this report. You will then make sure that in addition to your diagrams, you attach your calculations that we did in class together to this report. Okay? Here is the rubric that I'm going to be using to correct those calculation pages. So you may want to go through the calculation pages and make sure you have all of these in here so you'll receive the full credit for the calculations that we did in class. Next, we're going to move on to the discussion section. The discussion section is going to be talking about the calculations that we did, and we actually discussed some of this while we were doing the calculations. First of all, the discussion is going to be in paragraph form. It really should be in third-person paragraph form. This one I will not be quite as vigilant as I will the introduction if you slip up a little bit, but please try to do this in the third person. Okay, so there are two sections that we want to be talking about. The first is comparison of the total average speed and the average speed at the top of the flight. Now notice here it says make sure you write down what the expected and what the actual is. So you will be going to your rocket calculations and you'll be looking for total average speed and average speed to the top of the flight. So here's the presentation that we went through in class, and here is our average speed for the rocket that I did for you, and that's 3.1 meters per second. And then the average speed to the top of the flight, you'll notice, is 7 meters per second. Now, you need to use your results that you came up from your calculations, but in my case here, it clearly looks like that my speed to the top of flight is higher than the average speed. Now, here's where you would say the speed at the top of the flight is clearly higher than, at 7 meters per second, is clearly higher than 3.1 meters per second in your paragraph. And you would also include that this makes sense because the average speed is the rocket going up, and the parachute coming out, and then it coming back down. Whereas the average speed to the top of the flight is simply the rocket going up. So this going up and coming back down should be much slower than it just going up. Now, if you didn't find that, you should reflect a little bit and see if there's some reason why you think that your answer came out somewhat different than that. Next, we are going to move to the conclusion section, okay? And in this section here, we will be putting it in a paragraph form, and you will be answering the following things in the conclusion: how the average speed until parachute deployment is differed from the final velocity, why the rocket had kinetic energy, why the rocket had potential energy, why the rocket completed work, and how the power of the rocket could have changed. So let's start in our paragraph with the average speed until parachute deployment and then the final velocity. So we'll go back to our calculations, and all of these things should be based on your calculations. And if we go and look back to what our average speed was, we are going to be 7 meters per second. We're going to be, about 7 meters per second. And then if we look at what the final velocity was, you see it was 184.8 meters per second. Much, much, much higher. Now, this would be, and if you remembered, if you answered this question here, this helps you out with your conclusion. This tells you that, wow, that's a big difference. If you remember in class when we were talking, these things here, the calculations from the velocity, actually came from our calculations for acceleration, and both of these things were taken from our mass and the force. So none of these values are taking into effect the air resistance that's outside. So the final velocity here would be if we launched this with no air whatsoever. So in a perfect world, the average speed to the top of the flight should have been double, so it should have been about 14. But notice here, it's a long ways from 14, and that is clearly showing you that there is a huge effect from air on the rocket. Back to the report so you can look. The next one is why the rocket had kinetic energy. So we'll go look at our kinetic energy thing and see if we can figure out exactly why the rocket was having kinetic energy. Well, if we look at our kinetic energy equation, we have 1/2 mv squared. So we need mass, and our rocket clearly had mass because we measured it in the classroom, and the rocket had velocity. That's what we calculated. So the reason the rocket had kinetic energy, well, kinetic energy is energy of motion. The rocket was moving, and it had these two things. So you have to kind of summarize how come it has kinetic energy based on these factors here that you could measure, and the rocket was moving. Next, we're going to look at potential energy. We go back to our calculations that we were doing. We come and we look at potential energy. Well, you can clearly see here, potential energy is the mass times the gravity times the height. Your rocket had a mass, gravity was pulling down on it, and it reached a certain height. So from that information right there, you should be able to write a statement as to why your rocket had potential energy. Two more here that we want to talk about. Why did the rocket complete work? Once again, we'll go back and look at our presentation, and we will find out that work is the product of force and distance. Clearly, your rocket had a force, and it moved a distance. You can write a summarizing statement about that. And the last one, it says, how can we change the power of the rockets? So let's look at this for just a minute. The way we could change the power of the rocket. Well, clearly the power is from the work and the time. So we could do something to change the time, perhaps a rocket that launches longer, or we could look at the work and notice work comes from this force. And if we got a rocket engine that had more force, perhaps that would do something. So I would discuss something along the lines which is carrying out those two factors. Now this last part of your conclusion is 4 places measurements were made and how they might have been in error. For those of you who are having a hard time remembering the measurements, We used 2 of those for the measurement. And we used 1 of these. And while we were in class, we also used 1 of these. Now think about those for just a moment, and where were places that people might have made mistakes measuring those. If you do that, you should have no problem finishing this section. That should complete what you should have done for today's lesson. All right, today we are going to finish up our rocket project. Hopefully by this point in time, you have got most of your rocket project written up, and we'll just do the last 2 sections, the references and your reflections. So you should be down to this section here, and we're going to go to the reference. Reference is probably going to be one of the easiest parts of the entire project, especially if you're using this template, because really all you need to do is delete this part right there, and you've got it, because what you need for reference is a title that says reference, and you need this citation. This citation came from the website that I got the force data for this. That's why we have to include this, because the force data for the engines came from this website. Now we moved on to our last section's reflections, and this is where I want you to start looking at the terms that we talked about when we first started this unit and reflect how this rocket project relates to those. So we have, how does it relate to Newton's first law? If you don't remember that material, or you can't find your chart that has all the information on, you're welcome to go back to my homework page, and once you've done that, if you go quite a ways back to Wednesday, April 6th, you can click on presentation of mechanical energy, and here is the presentation. And down through here, if you scroll down a bit, you will get to the section where it's talking about the second and the third laws. So that will help you out there. And we're going to cover right here in this presentation Newton's first law. So, the first law, which we'll talk about more after we finish this project, most people are very familiar with, is that an object does not change its state of motion unless a force acts on it. So for your rocket, the rocket is clearly just sitting on the launch pad, not moving at all. So it does not change its motion until a force acts on it, and then when you have the rocket engine ignited, a force acts on it, and it very quickly changes its state of motion. So there is how it relates to its first law. Now let's go and look at the ones that we have for the second law. We'll take a little quick look here. See what second law says. An object is related to its mass and force applied to it. So we have F equals ma. We have the mass of the rocket times the acceleration. So we clearly had a mass, a force applied to it, and there was an acceleration. We used the second law when we were doing our calculations for acceleration. Right here, if you remember, we used it right there, and that clearly shows how the rocket had its use Newton's second law. Now the third law that we're talking about, how does it relate to that? We go back to our presentation and go to the third law. Hopefully remember this diagram here, and it's for every action is an opposite and equal reaction. We have the mass of the gas and the velocity of the gas coming out, the mass of the rocket and the velocity of the rocket going up. Action, reaction. In fact, you may have remembered we watched the Saturn V rocket take off with lots of gas coming down and the rocket slowly accelerating upwards. From this point, you can take and finish these out from things that are more of your opinion and observation. You are going to compare the performance of your group's rockets to how the other rockets in the class went up, make a comment on it if they were different and why that comment occurred. You will then make a comment on whether this lab helped you understand the concepts covered in class. And finally, you would like to make a comment for improvement. If you can't think of something for a comment on improvement, just comment on something that you really enjoyed about the project if you can't do that. Once you finish this report, if you happen to finish earlier than all your classmates, you are welcome to participate in the competition for the best presentation about mechanical energy terms. So you can go back to the mechanical energy terms that we have here and make your own presentation on that. And share it with Mr. Kelly at dkelly@sau53.org, and I'm going to select the best presentation from each class. But remember, this is only after you've finished your project. I want you to make sure you have your rocket project all done. All right, and that concludes this lesson for today.